Oh yeah, Let's Dance Blue. So that'll be a fun cookie load. I might load in one of those other ones when I go through my review if I choose one of them. But
Fuse, then there's a switch, and then it's going to go to the light bulb,
and if
and
it
then the
wasn't,
current travels back on this neutral conductor going back over to this battery.
This one specifically.
This is an electrical circuit. And if you could, I'd like you guys to take a pencil and a paper. I'd like you at home. I'd like you to write some fundamental things down.
And the beautiful thing about this one,
get something and write it down. And I'm
gonna have to give it a minute, buddy.
At the end. A lot of times I think
thing about safety, you're gonna hit me hard with it, and it's not that I don't care about this. This test very specifically understands and what outlines the most critical variations of the filling in of those math problems to the very specific math problem on the floor. The differential is workspace. Well,
goes to the load and returns back to that's called an electrical circuit. That's the way it works. Now,
the guy comes, clocks in, pulls down into the stone mill, does stuff, lunch break, does stuff,
that will cause those electrons to be moved in a closed circuit. If you move it one direction,
like I said, you come in, you fill in the thing, you step on the load, you do a bunch of stuff, throw a bunch of all this in the bucket, magic.
But no matter whether you're running a DC circuit, where the current leaves the source and returns to the source in one direction, or whether you're running an AC circuit where the current leaves the source, goes back to the source, and returns and alternates current, you still have the same case. Here is an example. You have a transformer which has a primary, and current leaves the previous source, returns to that source.
Well, the battery decays because that lasts the serviceability of this, and or one of these components that would fail serviceability rationally on the wobbles. Its lifespan changes. Feynman diagram a little different. It's on a different start. Chemistry gold oxidation. Why you need those? Because the current gonna hurt it. Environment gonna hurt it. IO. You know, so it's gonna be a bit shiny. You're gonna get the Mason's diagram, Terminator thing going right over here. This one too. Kind of different. Headsets are doing this. Environment in the room. Sets because on the floor that goes through the buckets. That goes through the reciprocals of that battery housing for a cost timeline.
That's the way it works. It's not going to ground. Okay, let's go to the next concept I want to work on. Has an electric shock.
I say the ground is table. Table different. We use the same thing different by different standards.
If somebody makes
you can. Sometimes it's good. Sometimes the
photons
photons are not always angry at you. Not always.
Light bulb, but also travel through the individual, travel to the foot, getting back to the source. That means that there's a parallel path. This person is in parallel with this
the dark
light.
side, the Faraday suit.
What's real important is we're going to get into grounding and bonding theory, and you guys are going to be like, what the heck is he talking about? I thought, listen,
watch video camera and just watch. You did this here,
right
you'll never do it again. You're rewiring a hotel, and the next time you're going to get a little Granny's house with a chihuahua just hammering off it.
I thought I understand, but I don't know what he's talking about. You need to get the electrical theory book, which is practical applications for the purposes of understanding the NEC. You're not going to understand this if you don't have a good understanding of electrical theory. This is not a theory course. This is a quick course of some fundamentals. We know that you know theory. All right, let's go back to our graph.
This isn't for me. This is for anybody watching this function. These are safety brief ground standard model sets of.
Think the laws of parallel says this.
Resistance is going to make it very conductivity, human body follow general relativity, Ohm's law.
Number 3. Voltage in a parallel circuit.
Voltage in a parallel circuit.
Remains
the same. The derivatives are the same. We're putting that derivative over the set. Like I said, those voltage equations later are close enough. They're area, concrete pores, voltage, amperage to the limits of those conductors by the NP problem. They were very smart. They were very smart.
You guys follow the logic there? Now, you can get shocked.
You'll turn on the light bulb for a little while before everything. Break circuit.
Or from hand to hand.
And the photons will go back to what they're doing. What they normally do.
Now watch this.
What they should do.
Electrons, are they trying to go to ground? Go back to our notes. What was the note that we said? Number 2, right?
Depending on circuitry, you might have an inline fuse.
The number 1, to the source. So looking at this graphic here,
universe.
You say, well, wait a minute now. Electrons are going to ground. No, they're not going to ground. They're doing what? They are using the Earth as a return path because this system is grounded, which means since you have the system grounded,
all playing off in the war room. Just
I'll
get
talk about what
saved a video, Three Finger Joe over here. We'll get this plane up over there. Shulkin, out military leader conversation land nav. We'll get sonar training, matrix,
they're taking the path
then
that it is to get to where? To the source. Now look at the graphic here. So they make a contact from the hand, it goes to the heart, to the foot, and it travels through the earth. They're not trying to go to ground. They are going to the source. Not trying to get to the source. They are going to the source. If you make it from hand to hand, again, this is
did an observation. Made a light bulb do. Tesla was on a rabbit track. Some other people had improved it by observing the happy photon and the not so happy photon. It wants to be alive.
Is dependent on the path through the body it flows.
That's a hard name to quantify. We were getting into biometrics of the exact numbers of you will take these many volts, this many G's. If you get electrocuted and it shoots you against the wall, any combination of that is a standard model matrix of the Torino scale now.
And from this hand to this foot, it would be what? 1,000 ohms. This represents the resistance from hand to hand. Now these values from the CEI 1984
eliminate it. I mean, take away all the fun.
Now, hand to your stomach is 500 ohms. That means that if you're leaning on a bar joist and you happen to touch something, your resistance just went down. From hand to hand is 1,000. Hand to your stomach is what? It's 500 ohms traveling through your heart. So you can see that.
All this, though. That's what makes that perfect. Because you're gonna, they're gonna be like, this job. I sit here and watch this video.
It takes a small amount of currents through your heart that cause you to die, to become electrocuted. And current is a function of impedance. Let's take a look at this next slide. Current,
so got the wire.
How many amps is traveling through your body, is dependent on the contact voltage and the resistance of the path that it flows through the body. So here, the resistance of this body is 1,000 ohms. How do we get that?
The MP problem gets into very heavy stuff.
CEI standard in 1984 was established.
We're getting this hard into. We're getting a bunch of shock keys about don't ever touch an electrical box.
Now,
ever.
This 1,000 ohms.
Get a little shock once. It's wet. It's wet outside. Get a little zap on 120.
You know, it could be 5,000.
Hand get tingly. Gotta keep pressing the button. Let it dry off for the break.
Less. Are you wet? Are you time electrician, hard, rough hands where you gotta touch the fingers and try to measure that voltage because your contact resistance is so high. But it's a variable.
As soon as I get it, even if I watch that, Ben Eater,
but we got to work with something. So we're working with 1,000 ohms as a standard. That's the number. It could be lower and it could be higher. But let's just go with 1,000.
Dragon build right there, man.
If you have 1,000 ohm resistor.
Like I said, they talk about it like an old bit. You know, somebody's got a video where he's got an old Mac on the board. This is really old. Got the stock market in it. I think it was him, but I'm not sure.
It's going to be 120 volts. If you take 1,000 ohm resistor and you apply 120 volts,
why would I give that person credit
then that
anyway?
means a current leaving the source, traveling through the person, through the body, returning back over to the source. Again, right? Electrons are not trying to go to ground. No, electrons are not going to ground. Electrons are going to the source.
Yeah,
we can do the math. I is equal to E over R. We're working with resistance. We're not going to worry about impedance, so it's all the same thing.
It should be the
current is 120 volt circuit. Typical circuit.
Come on in,
go. It's 120 milliamperes. In other words, it's 0.12 amperes. Well, what does that mean? It means nothing. It's 120 milliamperes. 120 milliamperes or 0.12 amperes.
I was like, well, I'm part of the damn universe. I'll be the zombie.
Let's apply the context we're looking for. Electrical sensation is 0.3 to 0.4 milliamperes. In other words, I sense something. I notice something. Somebody says, you know, I'm feeling a tingle. They can barely feel something. So that's less than 1/2 of 1/1000th of 1 ampere. Remember, hand-to-hand contact at 1,000 ohms at 120 volts is 120
That's the point. That's a kill agent, man. You put it in the wrong spot, wrong timeline, physics wrong, sharp guy.
1/1000th of an ampere. So that's just perception. Let's go to the slide again. The next thing is you can perceive it, but you're not uncomfortable. Then you go perception, and then you let go. You're like, hold on. Whoa, I just got shocked. So we don't know what that's about 1 milliampere. Now you notice that there's two different values, the smaller value to the higher value. We'll talk about that.
Let's give it a good one.
The next one
I'd
we'll look
say
at is the
dog
maximum
collars.
let go
Got the vibrating
threshold.
one. Well, it's like this one is.
You got on
Just
something
a little.
and you're like, oh,
Give you a
you're
good.
getting shocked, but above that value, you cannot let go.
That's what it's like. You want to
So
stick your hand in there and do
that's
that?
if
Don't
you
you see
can't let go. game over. You're going to die.
Game over.
Now let's go over to the last issue, which has to do with the fibrillation.
You can't handle house spiders.
Ventricular fibrillation.
Think of electrical fire monsters shooting out walls for you.
Off of an electrical signal, and it has its own power supply. So it has its own power supply, and it generates its own energy, and it also generates the electrical signals, and it tells its heart what to do. It's not the brain that does it. You've seen movies where they cut out the heart, and you see the heart pumping.
No, I don't like those ones either.
The body works off of 40 hertz frequency.
They go
So now the body's on 40 hertz frequency. We work 60 hertz AC, 50 hertz, 60 hertz AC in the United States, 50 hertz AC in Europe. So we're real close to tuning the frequency of AC circuits to the heart and the body's frequency at 40 hertz. And once you get past the skin and you get into the blood, now you get an electrolyte, which is a conductor. You start hitting nerves. Nerves are what? Nerves are designed to carry electricity. You start getting muscle fibers, which are parallel.
Them
and all you have to do is get 50 millionths of an ampere through the heart. We're not talking milliamperes. We're talking microcurrents. That's why when you get into healthcare facilities, it's a whole other.
Yeah, you get in those what are those golden rods and stuff way up top. Almost April and May when they're starting to nest up in there.
No matter
and
what
that big
happens,
mama,
once you get the heart to get confused. Now, imagine, the heart has its own power supply, has its own signal. It knows what it's doing. It's sending out signals in open and closed chamber. And all of a sudden, something comes in at the wrong time, at the right frequency. It gets the heart confused. Now the heart is trying to reset itself.
Never. I'm gonna fucking take them and shut it.
Right. And all it's going is like this. It's called ventricular fibrillation. It's not pumping blood. It's not hitting the right chambers the way it's supposed to be hitting the right chambers. What do? They do a defibrillator. Hit that thing and they boom. What are they trying to do? They're trying to stop.
Well, that's about
Once
gear.
Once they stop the heart to do what? They hit it a second time. Boom. Try to get the frequency.
In terms of ground safety fundamentals, we're talking about electricity. We're talking about overall safety for electricity, for everything.
For a fraction of a second.
No, we need more. Can we get a good diagram?
He gets a heart in ventricular fibrillation, and then it's over.
Well, there's a very specific piece of machinery that goes by every piece of machinery, code, standard, function. If you have one in your house, you need a defibrillator. That's where this level goes. Otherwise, administrate the possibility of that, or hand off the policy to the training function of, well, just do anything. Come in here to do anything. Have an electric box for reason to do a thing. They're getting trained to work that equipment, and I mean, at some point in time, the imaginary number turns into an observation. Earl, right? The Earl code. You floating around in here.
And then here's a girl. Okay, she's holding it. And over here you can see this guy right here. Now you know he's not letting go. Now you don't see all the photos in here, but the best part of this study, when you look at the photos, when you see the guys that are doing it and they're all like all contorted, you see all the other guys in the background. They're doing that. So you know if you had there were 40 students, 22 males and 18 females.
I mean, they electrocuted an elephant.
So the threshold values
this
are lower
was a big
for
one.
women than they are for
Back
men.
those times, that
but
was
the
just
studies
like,
actually show it's not because of the women being more sensitive than men. I got 5 daughters and a wife. I kind of understand how that thing works, really. It's that the woman is lighter than a man. The study was done where the woman's weight was 100
these boxes
pounds,
are made easy enough where they're sensible, and the observation is that is not the kind of setup you have right here. It's bad. Everything else is going to be a battery, which might give you a zap, a real nasty one maybe. Then you're going to start getting into a power source. Then you're going to start to beat, well, that's at any level. Before you did any of the battery experiments, and they've asked you to stand in mud, stick your hand in saw.
Of course, you can go all the way to fibrillation level. So, this has to do with mass.
But those little wires, the rules of the physics don't necessarily work that way, but those are little tiny pink and white and blue.
1 milliampere per 10 pounds is your let-go threshold. So, a 200-pound person would have a let-go threshold of what? 20 milliamperes.
Battery.
A 50-pound child would have a let-go threshold of what? 5 milliamperes. GFCIs operate at what? 5 milliamperes plus or minus 1.
Oh, but that's the whole point about the ground negotiation. He's very concerned with the hospital standards, statistics, numbers. Very specific cases come off to the, what do you got, 100,000 major accidents or 200,000 minor accidents, which means there's probably a handful of major accidents in there by statistics. Voltage works that way. Observation works that way. the fact that it's the difference of engineering and electricity, but there's not really a difference. If you really understood the same thing, kind of dangerous situations stand out a little bit more obviously.
How do you make it safe?
And so,
Turn the circuit off.
turned off.
That's it.
Kelvin, you bro, I'm looking at this quantum physics problem for an hour trying to figure out.
To make it safe, turn it off. I can end this DVD, the whole course, if you all finish right now. Because that's how you make it safe from electric shock. You turn it off. Let's talk about, how do you turn it off? Well, let's say we have a 100 amp breaker here. We're supplying a panel over here, and then there's a fault to the enclosure. We've already established current is in a circle. Is that right? Current leaves the source, travels to the enclosure, and look what it does. It's traveling on this conductive path right here, getting back to the source. If we have the conductive path, it's all electrical theory. Again, if you don't understand it, get the theory course. If you have a conductive path that's called a low impedance path, you got to understand what impedance means. Then when you have a fault current with a low impedance path is going to cause a high fault current. Now the way circuit breakers operate so that the higher the current, the quicker it takes for that device.
Well, they had a shitty day, stole $1 million, but while we're on it, you want to talk about?
And then it's 240 line to line. There's a fault between one phase to the ground. This is a 120 volt ground fault. Current's traveling on this conductive path right here. This is called an equipment grounding conductor, green wire, EMT, whatever. And then this is going to be called a system bonding jumper.
Won't pay Deadpool.
A supply side bonding jumper, which we'll talk about later on.
Others.
And then you're going to have a system bonding jumper. These are all titles that, you know what, we don't really care what they're called. What really matters is there's a fault that hits the enclosure.
We're talking about a high-end circuit, a very specific job with a house, with a thing. Either you built it, need the safety and insurance standards, or all the basic of whatever I missed inside there. Oh, this is a lot of information in terms of needing that printout. Me to draw this thing, you know?
To the enclosure, and look what it does. It's traveling on this conductive path right here, getting back to the source. If we have the conductive path, this is all electrical theory. Again, if you don't understand it, get the theory course. If you have a conductive path that's called a low impedance path, you got to understand what impedance means.
Yeah, well,
then when you have a fault current with a low impedance path is going to cause a high fault current. Now the way circuit breakers operate,
I'm not supposed to be here.
So that the higher the current, the quicker it takes for that device to
different people, different standards.
Have a 120 volt circuit here, and then it's 240 line to line.
There's no way you don't. Town system limit number, prime numbers for what town system output limit
on
is.
This conductive path right here. This is called an equipment grounding conductor, green wire, EMT, whatever. And then this is going to be called a system bonding jumper. A supply side bonding jumper, which we'll talk about later on.
Yep.
And then you're going to have a system bonding jumper. These are all titles.
I'm not doing any of this right now, nor am I ever going to be doing any of this in the near time future. And I know he says that that's not true, but that is
effective ground fault current path from the point of a fault back to the source, and the purpose of this effective ground fault current path is to turn it off. We want to have on a 100 amp breaker more than 100 amps in the event of a ground fault. We want as much as we can to turn the breaker off as quick as we can. Let's take a look at this example again. So, if I have a fault here and I have an effective ground fault current path here, so low impedance that would allow 583
I'm just picking out safety violations in the speed limit of the universal mega. Just saying.
And I'm not going to get into the math and how the currents flow. Talking about the concepts. That's how you turn it off. The only way to make something safe. What did we say? That was number 4? I think it was. To make it safe was what? To turn it off. So that's it. The only way to make it safe. The only way you can turn it off is what? If you want
I'm pretty doing decent.
A1.
They want certain things.
Turn it off?
Direct confirmation. Oh, you don't. You don't. I mean, like I said, you don't.
Have an effective ground fault current path.
You perspective, constant crushers. Now you gotta be careful with these kind of theses. But in terms of what it represents, you could say like psychological thesis. You gotta learn safety ground techniques. This is an hour and 13 minutes. How do you sit in a classroom without doing that? You don't. You take notes. I am functioning on not taking it off to the direct function on wherever it does. Usually when you look at this like circuitry, this comes up in relative water cooler conversations for A, B, and C functions for C code, for rookie operator. ground guy, master mason, manager, safety guy, however that breaks off into the rotation of your standard model. Chemical analysis report is acid test, you against the saw. Engineering of the physics, plasticity, timelines. You want to get the quotes for cut coefficients, how shadow problems of zero cuts correlate to a 5-man crew being off with chips on the line, and a 1-person crew, 2-person crew. That's the observation to say, well, it burns out the wire, I need a resistor. That's the safety, time, variables, cost line, system inventory. Time is what you have to, it's not, time is the stone metal when I say time. When I say time, it's the physics by electrons, the EM fields.
Grounded means that you actually connected something.
This becomes gravity, so I don't need it to be a simulator. I don't care if it is a simulator. EM waves, the density sheets, cosmic strings make perfect sense when you have schematics that will, the only way to define what it is, zap,
Now this steel is connected to the rebar,
would be that box, that observation of that's a universe, black hole, sun, neutron star, in the form of this, and black hole numbers to zap, omega.
This steel is now considered an electrode. And the electrode is also in the earth here.
The side of dead. The side of the, when I play it like a chess game, you get to bring it into something as if it's not a real thing. Hydrogen number 1 supremo. So if it was on the test and that chess piece occupied king position, anybody, odds and statistics. Well, like I said, computer engineering is a degree, cost line, other places on the map. I teach you that. Stay as long as you want while you're on a standard model for a timeline of the ladder, the brick and systems, how much you make as a thermaler, how much you make as an electrical engineer. What is the quote lines on those? Driving the car, circuitry around through the telephone, electron shell, position, electromagnetism, law of attraction. They want, yeah.
Talk about electrical circuit, you talk about electric shock, you talk about how to make it safe by turning it off, and then you're talking now about grounding. But grounding, you said, doesn't clear a fall. Grounding doesn't bring everything to potential.
Get into your house, Bill Gates, right? Like, oh, you're drill sergeant, fascist gravity, like electrogan, like, oh my god, right? Your cell phone, yeah.
Here is a little snippet that I took out of Industrial Power Systems Handbook by a gentleman named Beeman, who wrote this in 1952. This is one of the chapters, chapter 5. It says this: the word grounding is commonly used in electrical power systems to cover both
in the way I
system
got to be in
grounding and
stone mill.
grounding.
That's a horseman piece right there.
So now, make a note here.
Inches on standards of the Mason game, right? Stack a pallet, run treads. Get the number. And then you're pulling off cut coefficients. Then you're pulling off stock models. Then you're pulling off electrical engineering schematics on the dirty graph that you refine down into a Tesla's free radiant energy, earthquake, death rate.
Take a look at the secondary winding. You are taking this course to understand electrical theory.
Marshmallow
This is a system. If you take a look at the system secondary is insulated, and the conductors themselves are all insulated.
However, you only got my physics, don't do my physics.
None of these conductors are connected to any equipment.
$10 million. You can get the room for it. Not me. They must want you.
The system winding, the actual winding, is not connected to anything that could be an extension to the earth. In other words, it's not connected, Scott, right to the enclosure that has a connection to a conductor that has a connection to the earth. So therefore,
there's but one bunny, and you will be chasing that motherfucker right along with sticks, lighting fire. Whether they would catch him photons with a mirror housing lens.
Mike, we said, okay, we're talking about system grounding and ungrounding. Well, in system grounding, you could have an ungrounded system. That's system grounding, right? It's an ungrounded system. Now let's go to the next one.
Yeah, but you were in free fall.
What are the problems with
thermal velocity?
See, there's a problem with an ungrounded system. Is that equipment can easily be damaged from transient overvoltages caused by indirect lightning and restriking ground faults. Now, if you heard what I just said, you should have no clue what I'm talking about. But take a look at the next slide.
Doom, it's a business. It's where you plan timelines out to Dell. Like, I ain't Dell. He might not make it there, but for the most part, I'm planning him to go 10-year vet. Get the watch, bury him in a box. He smokes, he drinks, he has a good time. You don't like
There are many varied sources of overvoltage of sufficient magnitude to be damaging to the insulation of AC industrial power distribution systems. In this chapter, the mechanisms of which the prominent overvoltages are created will be described and preventive measures suggested.
Yeah, quick, get on the right system, and it's just the OP zero systems you have to need, leave them alone, figure out the rest of it. Usually do. It's usually what really happens. There's a lot of crew, a lot of hot selling.
I have no clue what most of that is even talking about.
I'm using my Jacobson organ. Leave me alone.
It's the problems associated with ungrounded systems. So let's go back to the graphic here. So if you go to an ungrounded system, you have problems. And so what Beeman is saying is, listen, we started the industry with ungrounded systems.
Human possession gets struck.
So he suggests what you need to do is you need to go to a grounded system. All right, let's talk about a grounded system. Now, a grounded system, take a look at this winding. Here's a Y secondary.
The proper engineering on the zeros and ones that say, how do you break the singularity, turn those zeros and ones into
look right here. We take the actual winding itself, we run a wire down,
all this at once.
Conductor over to a structural steel, which is ultimately connected to the earth.
Bunny.
So now we've taken
right, Bunny walked over there and I was like, one.
Now, why do you ground a system? You ground a system.
Maybe one of his legends was Lambda. Still around. Still in the hand of the name of the people that knew or at least couldn't compete.
You can have an overvoltage on the insulated system that's not grounded, and this capacitive charge is in
what would you do? I had a book and some stuff. Yeah, I can make a light bulb go by.
That there's going to be failure rate of equipment.
He's ultimately mad enough to charge it.
So you say, well, why would you not want an ungrounded system? There's reasons that you have ungrounded systems, and there's reasons why you don't want an ungrounded system. So I'm not going to get into systems, but pretty much for today's installation,
for most common work line, you don't get to do that. A hurricane is like, well, we all get to come in on some rainy days, but then the fucking roof just ripped off because the 30-year roof rating had a, Earl decided he wanted to play Final Destination on the floor.
It expands and it collapses that energy.
Nobody goes home too mad. Women just he was gonna go to work anyways. Talking about work, not just in your backyard by yourself, deciding to be a carpenter today, without a team, without your lair, grounded.
Then that induced energy on all those conductors is going to come back to the
system. So we're very specifically talking about grounding operations. Lightning, very important. Any weather, friction, make negative E. Right to the circuit. Could be a wind turbine, could be anything tall, follows the rules over 0 to 1. One of the largest ones.
The answer in 250-66A is what? 6 gauge. So if you have a 2,000 amp service and you're using 2 ground rods as your electrode, what size do you need?
Well, the difference would have been a foot. 6 foot gauge. You need X and Y for it. 6 gauge could be correlated well. I mean, if there is no difference between 0 and 1 there, pushing through the line, well, that would be the difference of 6 gauge. Well, if it's long enough, I mean, it'd probably burn out immediately and that loses the ground connection. But through that,
should not be any longer than necessary,
connected.
And we should
then
not
it's just
have
about,
any
like I said,
unnecessary bends. If you know anything about surge protection, you want the wires to be what? As short as
options.
possible.
Well, that option gave me nothing but a wire. I had 6 gauge.
Pulse of energy. So
if it's against those rules, it's against those rules, and you're probably going to get struck by lightning.
Well, what we want to do is have that wire short as possible.
How do you know if you never tested it? The first time I ever looked at a 6 gauge wire, I'm dead.
You go from 60 hertz to, let's say, 10,000 hertz or
how do you get the company running? What's one look
now
like?
That wire had a certain amount of resistance. The inductive reactance on that wire added to the resistance. The impedance on that wire is astronomical. See, what you don't want is a long
you gotta have that guy run his conversations. They use that guy for bar over Johnson Roads. If this is a safety operator, what's ground?
A well casing's 100 feet away.
They say they use that old school standard, that's fine, but the reality is I'm going to come down and say this is electrical engineering when it's ground safety. Whatever incident report you quantified as ground safety fundamentals is an incident report. Those are the hardcore, what do you call them?
Right there, 10 feet long. 2 ground rods.
Subcategory, but it's not subcategory. The
grounding. So we got to understand what is the purpose of grounding. Now that has to do with system grounding. And Beeman said there's 2 types of grounding. There's system grounding.
Show up to work. Do. I'll kick a lot of rock. Gonna trip a few times. One's gonna bounce off the rail, shoot off the bucket.
Now it's really metal equipment grounding is what we're we're talking about.
Don't usually grab a hold of those things, but I don't know what the hell they are.
Equipment are grounded to reduce arcing within the building structure from induced voltage from indirect lightning. Now, equipment grounding is different.
You remember sitting here for an hour just waiting for my first day to start? Just grab a hold of the machine. They're going to ask me to put something in the machine, take some out.
Ungrounded. You have a lot of different 9 or 8 different conditions of overvoltage.
Really? On the first day? You can't even look at my resume, right?
They found that out. Oh, man, that's a major problem. So we then go to what? We then go to system grounding. What is system grounding? You take these insulated systems and these insulated conductors, you make one connection from the XO terminal, you go to the earth, we can bleed off that energy. We're talking about conductors. You're not likely to kill anybody if you don't have proper system grounding.
They have to tap into you. They have to know your physics well enough to be able to say that. Like when I'm talking to you.
Take building with all kinds of metal all over the building, steel, piping, electrical boxes. There's no conductors in there at all.
You can. Go ahead.
None of this piping
if you like drain,
none of this metallic parts, none of the metallic parts is
practice program, just listen. What do you think? Well, CMC would do a lot of that.
It does what?
Grounded.
Pushes those
I'm not going to own all of it. You're electrocuted. You're dead.
It is a DC pulse.
It's intense. You're dead. This is the definite safe one. Tone exactly the same.
To the earth. If you don't make a connection to that, there might be some plumbing pipes in there or some other thing beside the electrical that has some connection to the earth. Inside the building, what happens then? There's side flashes called.
Outside. Outside of the house involved, maybe? No, it's perfect. No, we got a vacuum, a machine gun sitting out there. Nothing.
Has no place to go to, and it says, hey, I'll just go over to that steel column, or I'll go over to that plumbing pipe.
Right over that steel beam and just punch it just hard.
It could go through something combustible. It could cause a fire. In addition, if you're in a building that has metal electrical system and the equipment is not mounted, you have a lightning event outside inducing huge amount of voltage, you happen to be standing next to something while
electricity is
strikes
outside.
At that instant, you could have a side flash through you because you are the capacitor.
Maybe you're drinking a lot of Gatorade.
So equipment
I
grounding
can't say it doesn't. We should Mythbuster it.
That the metal parts of equipment, they're all what? Everything in the building is all connected together. Another word would be what? Bonded together.
Try to get
and
on
then we
YouTube,
take all
guys.
the metal parts and we do
Eat
what
a Tide Pod,
make sure
drink a
we
whole
go
bunch
to
of
the
Gatorade,
at one
stand out, get
spot
struck by
and
lightning.
only
You do
one
it.
spot only. Take a look at this graphic. And how do we do that? Well, at the service, you run a grounding electric conductor. Right?
You do not have one grounding electrical conductor. You kick your electricity right in the dick. You kick it right in the dick as hard as you
You're running
can.
feeder to a building, you do what? You run a grounding electric conductor from the equipment to the earth.
This guy.
This is called
You're a fucking apprentice. You train.
grounding. That we want to make sure that the equipment is connected to the earth. Now, are we carrying fault current? Are we grounding because we're going to try to clear a fault? No. You can't clear a fault with grounding. It's the earth. It's just a spot that you... It's a spot that you put DC high frequency pulse of energy just to the earth one way. We want that wire to be what? As short as possible. We don't want a whole bunch of bends. We want it to be right there. And so that is called the equipment
Texas,
grounding.
winter, Russia.
PVC from the
How about
service
a nuclear
to a
power
remote building
plant?
and bring an
I
equipment
mean, it's
grounding
anything
conductor,
different. You
PVC,
get struck by
right,
lightning.
so
Or the
ground
gray
right
cloud,
building.
great
Of
cloud effect.
course.
Electricity,
Understand something.
ones and
What do we
zero.
want to do with a grounding electric conductor as short as possible?
Well, journeyman
An
for the
electrode.
electrician's gonna
Not
follow
some
journeyman's
wire
version,
inside of a raceway
not
that
the
goes
swag
100 feet
version
from
of
one
picking
building
up
to the other building.
the
No, no, no.
master mason
That's
tricks
an
on
equipment
that
grounding
and picking it up from
Why
that.
do you have
Every
an
once in a
equipment
while, one
grounding
pops off.
conductor? That was
Most
to
of
make
them
it
go
safe.
through
It's
18
your
at the
protective
carpenter,
conductor.
masons,
Europeans label it as a
military.
PE, protective earth
Mom,
conductor.
that
It's your
wasn't
protective
being
conductor.
gender
Your
specific
green
at
ground
all.
wire is your equipment grounding
Both those
conductor. That
results
was, I
are,
think, number,
and
which one
they
was the one
are.
about
Where else
clear
could you
fault?
go?
Was it number
Wily
3?
monkey.
Have an equipment grounding conductor on our notes?
I write that shit
Number
down.
4?
Like a goddamn champ, they were on it though.
So, equipment
If I
grounding
can
is to provide a
think back, I
path
hadn't
from the
yelled.
energy that's induced on the metal parts to the earth. Now, let me explain something that's real important to understand. Grounding is electrical systems, according to NEC, is not for lightning protection. If lightning directly strikes an electrical system,
The dead.
whatever it does to it is what it does to it, and then you go and you fix it. The NEC is not a lightning protection standard. If you want to protect electrical equipment from a direct
You work
lightning
like a
strike,
nigga
then
named
you
Dobie.
put NFPA 780 lightning protection systems,
Get 'em,
and that
boys.
way it's
Cut it
designed
off.
to
Cut it
capture
off.
the
Don't
energy
cut it
of a
off.
direct lightning strike to air terminals, parallel those conductor paths to the earth,
Just
and
say
take
it,
the
guy.
energy.
Being a safe
We're
guy, you're
talking
gonna listen
about,
to me.
so
I'm
see,
gonna be
lightning
boss
goes-
tomorrow, and you're gonna
Where's
fucking
lightning?
love me.
Where's it come from? How does it work out? Okay, here we go. Energy from the Earth is going to be raised and brought into the atmosphere. Okay? The sun,
This is my
you have
blue
this
stone
energy.
mulch, bro.
Now you have the energy
I
raised in the
can take
atmosphere.
everybody.
It
Lodge
goes
is
up
fine.
and gets cold.
Perfectly
when it
fine.
gets cold, guess what happens? And the molecules become ice. The ice particles start bouncing across each other, and they start breaking
Wherever the fuck I want to put it, which is none of your goddamn business, which is a safety solution for you. Well, it doesn't matter. I'll just walk in one day. You won't know who the hell I am, when the hell it is. It'll just be this, and you will be fucking my puppet this deep up your ass.
Even from Earth to space, it's called
Does
sprites.
say.
Okay, so and you know what? Talk to anybody who knows lightning, they'll tell you.
AR-15 and take flag.
Let's understand something.
This
Nobody
is
knows
this
how it
house.
works.
This is this kid. I thought he was a dumbass. Your ass got
That
electrocuted
if
apparently
lightning
after
is
the
trying to
insurance
equalize
incident, and we
something,
patched
there's
you
a
up. The first
discharge.
thing is school.
If it directly hits something, it's going to do whatever it's going to do to it. But if we're trying to protect against electrical systems over voltage and equipment over voltage, when lightning doesn't strike the equipment, lightning strikes the earth and induces energy. That energy that's being induced is seeking the path to the earth.
You're playing a game, you call it a game. It's fucking life. Becomes engineering. Becomes, right now, is all free rating. All kinds get hammered if I didn't put that out there for engineering in 2020.
Here we go, ready? All right, here we go.
Just in the differential.
Provides a path
Like, if you don't call that right there to some bullshit hammered, you're gonna be, well, you gotta play the game of chess. Chess still around. Was it the multi-matrix of, this is your cabinet, this fuse breaks, turns off that light, you sure, 100% this one. Bit game, this is droid, that book is droid, because the same tippity taps go into the same straight lines, squigglies, except for that's a tree in my house. This one's the lock on my front door. Oh yeah, I know, we're right in the house. Okay, yeah, so, window open over here.
And if you're an electrician, electrical contractor, and I've done this at my seminars in different places, just grab a ground rod, take 120
Ever
volts,
look
connect
outside?
it to it, turn on the breaker.
No, it's not black mold problem.
It's not supposed to trip the breaker. Scott, did you do this at your shop before?
Oh yeah, we've done it before, sure. We've hooked it up directly to secondary.
You lay out there long enough, brother, you will grow moss.
What do the guys think?
Well, initially people go, of course it's going to trip. People, let's turn it on. What happened?
Well, Tony would.
Of course
I heard like a
it's
bit.
not going to trip. You can weld with it if you want to, but it's not going to trip.
All right. Myth number
That circuitry.
2. Current takes a path of
Lombardi.
least resistance. We've heard this all our lives. Matter of fact, I've said this when I used to teach grounding and bonding classes. I don't think so.
Maxwell.
Take a look at this.
If
And by the
you're
way,
going
this
to
is an
take part
example of
in
something
this,
on the
I'm
internet.
happy to have you here.
Properly ground electrical circuit boxes, devices, and service panel grounds that give
Can
the
you do
electrical
that?
current the easiest
I
path to
know.
ground, and that reduces the chance of someone getting shocked or getting electrocuted. That is absolutely false. Down at the bottom, the earth absorbs
What's
the
an
overcurrent
economic
or
on,
short
brother?
circuit
Like, I'll raise
harmlessly,
the debt.
and having done so, eliminates
Like
the
your
threat
ass.
to
This
anyone that
Murphy
may
ass,
have
you call
otherwise
him dumb
been
shit. I'm bringing
the
back,
grounded
make him
path.
general.
Are
This is
you
what
kidding
cowboy.
me? This is live stuff on the internet. What people are saying.
You are
that
coming
grounding
in way
provides
too
path
hot,
to the
Larry.
earth,
Wait,
it
I gotta
makes it
work on
safe.
your PR.
Doesn't
I
make
love
it
your
safe. Let's
energy.
take a look at the
Great.
graphic.
Love the graphic.
Here's a pole.
This not there.
This is a
Look at
typical
the
utility
look at the kilo.
installation. The electric utilities do not have an equipment grounding conductor, but they'll drive a ground rod next to it and connect it to the pole. Well, if you have a 120-volt fault,
You're doing good. I love the presentation. PowerPoint, Word, Excel. You get the well, you don't have the Excel.
That was the math right there.
It's in 4.8. It's in 9. But how you got those number by series testing is this guy doing something really fucking stupid
That happened in Illinois,
with what he knows.
where Illinois had traffic signals, and they didn't have any ground rods at all, and a male dog took a leak and died. And they're like, oh my gosh, man, so it could have been a person. They went around and drove ground rods. That was in 1970.
Well, their job as electrician.
In the year 2000, another male dog took a leak
Bet
on a
you
pole
didn't
in
know this like that
Illinois.
shit with the Bible, and he was
Got
preaching
killed,
today.
owned by a female attorney. This is the kind of stuff you don't want to do. Kill dogs that owned by female attorneys. Guess what? They got me involved in it. They ran an equipment grounding conductor to every single thing, to all the equipment. Do they still
Yeah,
drive
he built
ground
the
rods?
B apparently. That's right, man. You just lit.
Because we've been driving ground rods at poles. It didn't work before, but it doesn't matter. We drive ground rods. No, ground rod serves no
But
purpose.
grab it.
What serves a purpose is what? An equipment grounding conductor. So anybody making a statement that grounding makes it safe, electrons are trying to go to ground, is false. Here's another myth.
Shoot at it, misses.
Grounding brings everything to a zero potential. This reduces touch and step voltage to a safe value. Absolutely false. Here's an example.
If I shoot the
If you have
arrow,
a
it
pole
fucks it
that's
up.
grounded with
I
no
bust up
equipment
my
grounding
last
conductor,
wire.
you will not clear
That's
the
all
pole,
I got.
and you will
Johnny, I
create a
can't make it to the
voltage
store.
gradient
People are out of oxygen. I'm about to save the world, man. I'm stripping wires with my teeth and it'll lit into the
that
wall.
voltage gradient will be about 75% of the applied voltage. So on a 120 volt circuit, 75% will be 90
Zombies.
volts. How does that work out? Well, this gets really, really, really complicated. So
That program?
you might be like,
yeah.
I don't understand what it is. Oh, just trust me. You know what? Don't even trust me.
Not
Go drive a
program.
ground rod.
It's program.
Put an ammeter on there.
It'd be the book
measure
I'd
the
use
current,
it.
go
But
3 feet away,
I'm not right.
realize
This
it's
is
90
getting more of my
volts, 3 feet
fucking
away,
testing
and
this
realize
robot chick farting in
there's
every
something
goddamn
in the first
cave
place
for my
because
summer
you can be
vacation.
killed. So you got to really, really be under some kind of controlled
No.
environment to understand. Think about it, you're taking a 120 volt wire,
Usually does.
you're putting it
I
on a
hold it
rod,
on and
which
it
means
fell
the
off
rod
and
is
you
how many
bitch about
volts?
that.
120 volts. The voltage doesn't go away. You can't get rid of voltage. And now you stick it in the dirt.
Oh, yeah.
It's 120 volts at the rod, but it's 0 volts at the source, which means what? There's a voltage
I said
gradient,
box.
and
I
it's
put
not
that box
linear.
right up
It is
there.
this huge
I said
gradient
that
rise
you'll be the devil
right
and
near the
you
electrode.
will be over
and it has
here
a
hanging out
function
with
of the
me so they
resistance,
can't say
contact
you were
resistance of
doing
the
jack
electrode to the
shit.
soil.
And we were
And this is in
programming it
the,
like that. You.
Green book, IEEE
know.
Green book. I think it's 142 is the book number. And I think this is table 4 or something like that. And it shows you
keep being
distance
pretty.
from electrode,
No
what
one
the
on Cuba.
percentage of the
Pretty
resistance
pretty.
is. If you go
What's
1/10
Cuba?
of a foot away from
Whatever. I
electrode,
was just trying to
that
be,
represents
you know,
25%
coin.
of
Get
the
the fuck out of my
resistance
office.
of that circuit, which is the earth. If you go a half of a foot away, it represents 52% of the resistance of the earth.
No.
And if you go 5 feet away, it represents 86%. All right. Here it is. 1/10 of a foot away is 25% of the resistance. 25% of the voltage
I'm gonna
is
just
equal to 30 volts.
hit a turkey with a semi and toss it out from. Tell them it's who grew duck or some
What we're
shit.
saying is that you drive a ground rod, it's 25
You
volts.
don't care. You don't care.
But the earth itself has 0 impedance. The earth is fine. You can use the earth as a conductor. Tesla, he's all into that stuff, trying to use the earth as a conductor, set up the magnetic field,
yeah.
right, the waveform, and be able to get back. The problem with Tesla is that
Probably smacking that back.
the earth doesn't come with connection. So you gotta do it. So now you gotta stick something in the earth. If you stick something in the earth, guess what? It's a high contact resistance. The earth has all these parallel paths. That's why the earth itself is a good conductor, because it has what? 8,000 miles of diameter of a parallel path, which is great. But the problem is when you make a connection at each end, or when you make a connection at one end, that contact resistance is high. And when you make the immediate connection to that location, what you have is you have very little soil right there. And then it gets what? More soil. Then you get more soil and more paths and more paths and more paths. Take a look at the graphic here. So if you're 1 foot away, you have a certain amount of paths. And 1 foot away represents 68% of the resistance. And if you go 3 feet away, well, now you've done what? You've increased your paths. In other words, you got more paths to work from, okay? If you have more paths to work from, well, then it's resistance. When you get about 25 feet away, basically, now guess what? Now you're in the earth. Now you're back into all those parallel paths. So it takes about 25 feet radius, which is what? A 50 foot in diameter. So now, if you understand that the voltage drop of a circuit, okay, Kirchhoff's law of a closed loop circuit says that the voltage drop of all the resistors in a circuit equal the voltage source. 120 volt circuit, what's the voltage drop of all the resistors? 120. If you know the distribution of the resistance of the circuit, well, then you know the distribution of voltage, because voltage is directly proportional to the resistance. So let's look at this table here. I know this is a complicated concept, trust me. If 1/10 of a foot away, because of the contact to the soil, represents 25% of the resistance of the circuit, and we're only talking about the earth, well, then 25% of the voltage of the circuit is 30 volts. And if you go half a foot away, it's 52% of the resistance of the contact. Well, then it's 52% of the voltage, which is 62 volts, and then 3 feet goes to 90 volts. So let's go over here. This is not the scale, and I'd like to have this with a scale. Maybe we can make one a scale. This is, let's say this was, for purposes of convenience, if this was 120 feet long, you with me, guys? And 120 volt fault, then what would be the voltage drop of the 120 feet earth only? What's the voltage drop in volts? How many volts?
120 across all.
Okay, now, here's what I thought. Well, if I have 120 feet and 120 volts, well, then there'd be how many voltage drop per foot? In my mind, would be what? 1 volt drop per foot, right? I mean, voltage drop is linear. But the problem is this. The earth is a good conductor. It's the contact at one point that's the high resistance. So voltage is not linear. Voltage is a function of, well, how much resistance does it represent? And the representative resistance is shown on this table here. Well, the first shell of resistance was 1 foot. 68% of the resistance, well, 68% of resistance is going to be 68% of the voltage. And if you go 3 feet away, well, that represented 75% of the resistance, which is 90 volts, which is 90 volts. And so that's why grounding does not bring anything to a zero potential. All it does, it creates a voltage gradient. So no, let's go to myth number 4. More grounding, the better. I mean, come on. I mean, like, we all done that. Like, wow, you know what? 82 octane, 87 octane, 90 octane, 91. Hey, they got there's some special fuel that, that you can get 107 octane, 140 octane. No, you don't want to put higher octane in your vehicle. You're spending more money, and there's a good chance you're going to
So how's your safety brief been so far?
How many guys know that in here? Raise your hand if you know that.
I'm too cheap to buy it anyway.
I know, but some people would think, well, you know what? But if you got more money, you might say, hey, you know what? I want to do a little better job. My car, I love
Gotta
my
the fundamentals before you hit the
No, it doesn't work.
complicated. Like I said, I figured it'd be good. While I was thinking about it, just wanna separate these two things for safety fundamental for psychological on schizophrenia, manic bipolar. It's nice to have something correlated, big terms in the background that work exactly the same way by math.
False. Auxiliary electrode, CNC machines, computer numeric control.
Safety.
I've been in
Number one priority.
in Seattle, Washington area there, and I've been running around in Reddick and all the different places, and we're talking
Different crew, different type.
computer control
Shouldn't be here
machines
for
with all kinds of
doing that.
great
When you're
great
inside of the drill bit
they cost
factory, that
millions
they're gonna
and
actually
millions of dollars.
things are gonna happen. $10,000 pieces of saws and water. Some are board factories, some are steel, some are very different. But the manufacturing operation still have the same housing cabinet.
25% like
Omega, just blanketing in there. Being photons, and that makes this wiggly squiggly thing do a thing. When that stops, everything's dangerous. Everything stops. Safety guy, no, stop. Stop, pause. Hey, I only work here 8 hours a day, boss. I didn't. Uncertified. You called me. I was like, no.
But if you do,
Exactly.
the code has rules about that. We'll talk about those specific later on. Scott.
Yeah, I was gonna say, Mike, this really happens in a very practical sense. You get equipment that comes in from overseas. It's got instructions. It says add a ground.
Chinese
connect,
blue
put a ground
stone right
rod in.
here, buddy.
And as an
Caught it from
electrician,
Hancock,
if
New
you
York.
do that,
Tompkins,
you wanna let
Johnson,
'em know,
Delaware
listen, we're only
Basin
doing this, of
Stone.
course, with your instructions.
If it's
This
running
is
blue
not
stone.
needed, it's not required by the NEC.
Saws,
The
tables,
next thing
honing
you know,
machines,
the
hand
machine doesn't
honers,
work
rock
out, and they come
facing,
out and try to
rock
tell you, "Oh, you
facing,
hooked your
with a
equipment
set
ground
and a
conductor," which is
5-pound
just
hammer,
adding to the
3-pound
middle
hammer.
and creating even more problems. So, as contractors,
Physics problem.
even though some of these
Mechanical
concepts are a
action,
little
levered,
complicated, you have
little
to be very,
NASA
very
stuff
careful.
that's
You
like,
cannot avoid the rules
Cobra.
of the NEC just because some manufacturer from overseas says you drive a ground rod, you
Under
unhook
denial,
everything else,
20
you mess
silver
up
pieces,
my
please.
machines, because it's a real liability issue as a contractor.
All right, let's look at this graphic and let's really bring what Scott is saying. He's saying, look,
IMA. Train.
equipment comes in and the manufacturer says, we
Gotta
need
have
to
it.
make sure
Test
you
model.
ground
I
it.
can
And
catch
then
it
things
from
have a
you.
problem
Your
with the
model said
equipment.
this.
They
Come
say,
to me.
our problem
Everybody
is
gets a
grounding.
marshmallow.
Your electrical system is a dirty ground. There's noise on that. We need to
You didn't.
disconnect that.
You're not certified to know how to do that box, that robot. You didn't work at this company long enough to put it in the safety manual. Chemical analysis report electrolysis.
In case there's a fault. I think number 5 was what? Bring an equipment grounding conductor to it. There's nothing else you can do.
Well,
You
like I
cannot
said, kill
violate
you. Bring
number
back
4,
alive,
number
kill
5
you.
notes that we have. You can't violate it because if you don't bring an equipment, effective ground fault current path there, you don't bring an equipment grounding conductor, then you don't go to number 4, you don't turn it off,
Water to
you're going to
wine,
kill
right?
somebody. But
Grape
they're not
juice.
thinking about that because everybody thinks what? No. Grounding brings everything to zero potential. It assists in clearing a fault. You know, I mean, electrons are trying to go to ground. All that wrong stuff is causing people to make it dangerous. You need to make sure anybody tells you to give me the equipment grounding conductor, you tell them, absolutely not.
Mason's game.
Total confidence. You're the expert. They're not
These
the
are-
expert. You're never going to disconnect that wire.
Your
Never gonna happen.
complex versus
They're gonna go
my
nuts. I don't care.
my
I'm not going to kill
my
anybody.
IMA program. Just
Now,
I mean, it's
every
like bringing the
electrical
Ninth
power
Legion in
research
though. But at the same
institute
time, there are certain
has
rules that are
documented
lawful,
power
certain
quality
things that are not.
considerations
You're gonna
for
understand things
CNC
about
machines.
physics,
It's a
and FMA is everything.
BR107. That's a number. EPRI is the electrical power
There's nothing,
research
no way that it
agency.
wasn't
They're
like
blue
graph
out
it,
here.
is this its
They're
object, it's gonna
organizations
move.
that do
I'm
all
gonna walk
kinds
in
of
this
studies
direction
on
and bump into
electrical
this
power.
wall like a
And
damn
every
robot,
study
because
says
I
this.
believe
This
in
is
it
a cut paste.
like that, and if that is
However,
what's so
field
happening on the
experiments,
CNC or saw program,
experience
it's gonna
sites
wad
with
up
the
that saw.
supplemental
And if
ground
I was
rods
trained
have
by
shown
this
that the
system
rod
and I
can
handed this
actually
to the work
increase the
fraud
risk
case
of
guy and I
CNC
was like, I
electronic
want you to
damage.
do it now that you know that
These sites
you've
are
never
found
done
to be
this.
prone to have damage of internal electronics after thunderstorms.
So you go
or
say instant
utility
report,
system
and
faults.
that saw
Now, here
never
these
goes
guys
out of
got-
that block station.
They really
It comes
believe
in,
that
it
ground
goes
rod
out, it
is
shits
the
a
same,
diamond,
and that's how it
you
all
get
works. They
paid,
don't understand. No, studies have shown they
nobody
don't
gets
wanna do this.
electrocuted.
Makes it worse. Look at the
It
slide.
worked just fine.
Now the question, the statement is this: what this study says, what is believed to occur
In
is
water,
a rise in earth-ground potential
weld
near the
underwater,
electrode,
you can do all
causing a
kind of
large current to
irrigation
flow
from
on
one
the
side of
ground
Rome to the
conductor
other.
between the electrodes and passing through the CNC machine. And it says down here, see figure 7. So here's figure 7.
Pretty good.
Whether it be a lightning striking the earth,
Makes sense.
or whether it be a fault of the
I
utility.
mean, we kind of
What
wish
happens?
they
The fault
could, though,
current-
right?
Where's fault trying to go to, guys?
Not
Not trying to go to ground. So if the utility has a wire that's
bang.
on the ground,
That's a software.
it's not
Every
not
time
trying to
it
go to
pops
ground.
open to
It's
that
trying
one.
to get back to where? The source. Every single electrode that's connected to the earth, guess what? That entire
Like, so that's front end of the saw. You're the ant on the wire, right? You're traveling into the building. This is the big saw. 25 footers. And then your overhead view on that's going to be this, with a different couple of quotes and topologies of safety positions.
Oh, here's another one, and go up that one also.
Internal spin. This is an air turbulence equation, heat equation,
Generators. I
special
can't tell you how
relativity
many
equation,
people want to drive
dark
around without
energy
a generator.
equation.
You got a $10,000
Well, it depends on the lightning bolt flow, right?
generator, standby power. And there's
The
why
gauge,
is
your
there a lug?
pinky, your
There's
thumb.
a lug on there because the UL standard is there'd be a lug on there because there
Cloud.
might be an application when you're supposed to use a lug. Okay, you don't always put a wire on a
The
lug.
video,
and the
maybe
lug
you
is
could
there.
tell,
You put a wire on a lug and
but
connect it
from
here. If it's
that
required by the
housing of
EDC,
that scout house outside in that box, it's got to be in there. You got to have it painted orange, 300 IQ on what that is. You can't get electrocuted by anything that would get electrocuted. Ground safety. Battery disconnected? No. Grab hold of the brake light and get it there. And stick your finger, your pliers in the. We're talking about some heavy duty sets right there, though.
This creates a voltage gradient.
Well, they
Goes
have
over,
solar power nowadays has a big kind of kick in the chin. I've seen a couple of YouTubes for it out there about the power supply. Bitfarm's going to be the other one on that. Well, it's a lot of power coming through there to bolt that, but most of them are electricians, and they would know most of the safety standards, like Gauss law and Maxwell's equation, and the old school beating wrench for where you usually got to be, or at least where your family's going to be trained to know the basic information to everyday around you electrons. Get it right, not get hurt.
2014 code is going to allow, because auxiliary
Goats,
electrodes
huh?
are permitted. In other words, this is not a violation of the code. You can add electrode if you want to. You want to go to that CNC machine, Scott? Let's go back here. Want to put electrode there? Okay.
I'll
code
put
lines,
electrode there.
We don't think it's a good
I'll
idea,
be
but
there. Yeah, I believe you're a builder. I think you could put that like
Thank you
that.
very much. You put in a generator, here's the problem. Now the 2014 code is allowing you, recognizing that you might want to take the array and connect it to the earth. Oh my God.
Not the building you are standing in, not the building you are about to work in. This is safety about everything in the universe. On the internet, specifically described for that, which is like, no, cat, you are a three-finger Joe right now.
Now take a look.
Finger right there.
Travels in the earth. It goes up that beautiful connection you made. Goes through your PV array system. It goes down to the
Alice in Wonderland syndrome, kind of a whole thing. And what's time around here? Doesn't matter as long as it works for you. Kick in the. You would kick. I mean, you would kick. Boss, pick up that piece of paper and throw it away as you're rolling by it. Well, I'm just.
You don't take an array and then write.
I tried it. And they just walk right on by. Make a cigarette butt on it. Go away. Go away.
You know, so that doesn't. You got to go to NFPA 780. Let's go to the next myth. We're almost done with this whole stuff here. Grounding a light pole is necessary and required by the NEC. False. In other words, you know, why do we drive a ground without a pole? Well, I'm thinking the reason why, because that's the way.
Well, let's look at the injury severities of how much electricity could possibly ever be packing through that power pole right there. And this guy
quoted CNC.
wowing away on.
Why do they put a generator? They really
This
believe
guy
it.
holding it like in
They
his
really
palm.
believe that more grounding is better. But let's just use the
He's
logic.
getting
Let's
grounded.
take the pole with a simple example, okay? Let's look. Guy drives a ground rod.
And he's wearing the white hat. What is that?
Look at that lightning bolt coming all the way down, hitting that array on the top of a house, hitting that generator, hitting that light pole.
If there's ever a better
Do
reason
you
for gravity,
really think that if you put a ground
it
rod
does.
at the
It has a
bottom
lot
of that
of tornadoes,
light
gravity,
pole,
hurricane,
come on, guys.
gravity.
I mean, I know that
Cause
some
of
of
the
you guys watching
sun,
this
the
DVD
black
or
hole,
watching this live stream
not
or
any of
watching
that,
this on
nothing.
the internet are saying, wait a minute, you can't possibly.
Well, the equation works, not to a direct. I can get there from field theory equation. I can get there from Nova Strokers. I can get there from the NPE. I can get there from Hutter's Prize and condensing 100 megabytes into 10-ish
Alright, I don't think so.
units.
I've seen this.
What are they meaning in the Bitcoin? Their limitations are a YouTube file, which is a very specific set. And we're talking about code compression and file algorithms and prime functions, which will get you killed if your job is to be a fucking programmer and you don't know it, right?
Bolts that go down 15 feet in the concrete. Who knows
Flex
how
bands.
massive of a cage it is to hold this whole thing. It's all tied together. You got 12 of these bolts. You really think you're going to run a 6-gauge wire or a 4-gauge wire off of that? You're going to CAD weld it and stick it to something?
Think you're gonna walk into a room of electrical engineers that built the building and do electrical plating and just think, right? Fuck no.
Ground rod at a fiberglass bolt.
You out of your damn mind?
That was Dennis.
Why?
Yeah.
Why am I?
Fiberglass bolt.
Why are we?
Come on. Eric?
Mike, there's a comment from the field that Generac does include ground rods in the instructions.
The comment was made that
You
Generac
smile.
does
Any one of
include
you smile like I
instructions
want
that
it.
grounding is in
And get
there.
that. We'll figure
Everyone
that out.
has a
Start
video
probing that
screen cap
off.
making
Well,
this
you can
comment.
get together.
My
I just don't
comment to
know
you
if y'all like
is
each other
probably
all the way yet. But
Take a
we'll
look
figure
at
it out.
the new instructions. Generac has changed their instructions because I work.
That bunny, he's everywhere at the table. Don't worry. One of you Peter, one of you Paul, one of you John, Luke, Mary, Tom, Dick, Harry, Larry down the road, everybody knows Dave, Don the mechanic. He'll pop up on here, man. Just fucking
So I'm
no.
pretty comfortable. But if here's the problem, Mike. What do you do if I do have a
If
generator?
I had his number and you knew his number was gonna be God kicking you in the nuts out.
Scott, what do you got to do?
Buddha, if you're in that area, Buddha works for you.
idea?
Alright, well, there's the same math problem, Maxwell.
It's the old liability
I mean,
problem.
you're gonna use it right. You
Manufacturer's
take your hand to that electrical bar.
You follow the manufacturer's instructions, but do not forget to follow the NC.
To ohm the resistance.
All right, let's take a look at this. This is something I recently received an email with some documentation, and this is what was said in the material about this product that was designed for ground. Let's read it. Sparks.
He's not gonna call it out.
Bonding.
Yeah, instead of one.
Connect components together to eliminate voltage differences. Would you agree that if we tie components together, to be the difference in voltage?
So IMA is a different type of program. It gives you the opportunity by test of a certain index of what that test looks like. Now, I haven't signed off anybody.
The fiberglass bolt all connected
I haven't
together.
signed
and
off
the
one
shaft and
person
the
in my
motor
leisure.
And the rudder and everything's connected together.
Nor have I got
and
the
guy hooks
comment
up shore
or the
power and he
conversation
makes
say
a
I
mistake
have.
in the
Nor have I
connection,
said
and he makes
that
the
I have.
equipment grounding
I've
conductor
done
as the hot
the
conductor,
function, which is very safe.
plugs it in,
Very
puts
safe
everything
place.
in the boat be energized,
You can
and
do
the
this.
person standing in this fiberglass boat will not feel any voltage at all. So, the problem is this what? The rudder,
As a safety officer,
shaft,
let's pause.
propeller.
If there was a psychologist, just because that's the beauty. That's the beauty. How much electricity did you learn? How many voltage is in the first psi? Everybody died.
They're connected to the motor, which is connected to the electrical system. It's what? It's 120 volts.
Watching me, graphing me, writing that.
He ended up killing his wife, his
We're
daughter,
good.
and one other daughter survived.
Because he got electrocuted?
Remember when you drive a ground rod, you put 120 volts, you get this voltage gradient immediately
Oh yeah,
around the
because
electrode,
he
and you get more
electrocuted
parallel paths.
everybody. Alright, I
Same
got
thing
it.
happens in
Yep,
water,
we're good.
particularly
I thought he was on a
fresh water,
killing
not
spree at
saltwater,
this point.
Particularly in, it happens, but the danger happens in fresh water. So bonding does bring things together between the two parts, but the problem is you might be
Was he a
standing on the
dumbass?
earth,
Was
but
the side
something gets
dumbass?
bonded,
The
and then
side-
you're dead. Let's look at the next part of this. So the concept of bonding is true.
Talking about electricity.
Statement on grounding. Attaching a ground.
Could you do
reduces
that?
the
Can we do
possibility
this
of
as the new
voltage on
safety?
equipment in
I
the
hope
first
this
place.
is the one I have to
If I
watch.
tie these two things together,
On that
now they're
amp and
both
all.
energized, and I drive a ground
Oh,
rod,
that'd be
does
perfect.
that mean now I remove the voltage from the parts? No. Here's another one. Step potential. Placing ground devices in locations
Yeah.
that are not usually...
Well, that's a good stop point for what it is. True faults are good questionnaires, but they're not real. Well, faults. Well, they're both fucking faults. I don't have the right answer compared to a true answer. So I can understand some basic things about circuitry. That's kind of like ABC school. Obviously, down and dirty, running the machinery. You're not in you are not into the circuitry form, the inventory of needing the exact breadboard, resistor, core, book thing of all the MOSFET switches and capacitors in the universe. And if there are any of them in there and at any point in time they ask you to do anything at that point in time, is the breaker off? Because you'll fry a lot worse. Not necessarily that any of those apps could get you unless you go about cutting wire with snips, which at the point they give you a pair of snips and tell you to get in there and you're like, me, no. Fuck no, I am the person you have hired for this job, nor do I mean, I could look. And if I have to blindly operate, I will watch whatever you consider the electrician in town, whatever you, and then at that point in time, I need to do this again at that ideal. That is a great place to start, true false. But at the at the point, I need to know what the basic limits of those things could be before you have me going tearing down the building on highline commissions of a house, or going through those details before the code on the index of building or decommissioning something under that function says I would tear that down. And some people do. That's why we have the first idea. Somebody would say, is that up to code? And maybe. And it would come off first, but you wouldn't notice that because it's an irrational number. At that point, the court case on Judge Judy is very different in POV. The court case is written down in a wiggly squiggly line. Again, well, how big is it? What is the intensity in which I was carving this message through to get this kind of message on squishy cat stuff? Incidents of incidents plus 1010 this, and then nothing happened for a while, or this, and then immediately every single there was no in between. They just they robbed the bank, stabbed everybody, jumped the car over the ravine, jumped out with parachutes, landed it, did some boaty shit, and climbed the mountain on some ridiculous line, and Tesla ruined it for everybody.
Frequented minimizes the resistance of the ground to minimize the voltage rise and possibly a dangerous step potential. If I drive a ground rod and I connect to something, does that mean I'm not going to have any voltage
You and JP
between the metal parts and the earth? Or the step potential? No. Bonding devices together so there are multiple grounding points can lower overall resistance to ground and minimize step potential
FMA,
difference.
we're all on
In
the
other words,
planet
the
at
more
the same
ground
damn
you
time
put,
making trouble.
well,
I'd
then
assume
now,
the
you
lightning
don't
and
worry
the
about touching that
hurricane.
because you got a generator and you put 5 ground rods all over the place, and of course there's oh no, we have this
If you're good with putting them in a jar, you'll have a battery.
was a CNC machine, okay? And so we
Hoover
put
Dam.
one ground, and then they had a problem disconnecting equipment.
Oh, you didn't get that before you just stuck that thing in there and killed your whole family. Ah, I understand. I get it. No, that makes no sense whatsoever.
Touch potential. Grounding. Minimizes ground resistance, will help trip breakers faster, minimizing duration of hazard. That's like the number one thing you can possibly say.
Well, you're not training me to do the fucking thing that could get me electrocuted when I was asking you goddamn questions, Larry. You took me on an hour and a half journey through Alice in Wonderland about
limiting voltage rise and duration of hazard. That is false. This is the problem that I'm
in front of a board, no less. Like there are 12 of you. You're all judging me right now, like I'm the jackass.
And that is that you go to try to talk to
I'm
somebody.
sure you got the Kool-Aid. This is fundamental standard. If you're out the gate tomorrow, you'll have no problem. I'm just an imaginary number.
I just showed you a brochure.
Of course they would be.
You try to call the manufacturer, which I did. You try to explain to the guy, you're going to kill somebody. Stop with your advertising. Stop promoting.
About to kill somebody on the quote.
I found out, and last time we were having dinner, and Eric was saying something about a welder, and then later on, this guy
no lawful order inside of there says you need to kill yourself or you, given any order. There is no boss, no Kool-Aid in which you have to drink that says that is where the options are if you feel your case is lawful. Well, let's be honest. The reason it doesn't go there is because you knew the rule and you probably knew exactly the incident report. And electricity doesn't care. Anything in there doesn't care. It's a mousetrap.
It's a closed loop. People think that you weld and the spark ends at the point of the gap, everything has to come right back into the machine. So it's a portable electron pump, and whatever electrons you put in the system have to get back.
Why would the welder think something is ground?
Because
there
in
are
welding,
tightest,
a lot of
smallest
times
frames.
you have your two leads.
Let's say your question. The general relativity set, building, house, code, look it up, read it before you do anything. And if you didn't, you're probably gapping something to how much you're going to get.
It connects to your work. It's for the purpose.
It connects to the metal part that you're welding.
Yes,
or
it's
the
for
table that it's...
That's right. It's for the purpose of bringing the electrons, if you will.
We call it plutonium touch because you're radioactive. Mark your feet, demon core,
people are thinking,
nothing.
I need to find some ground to connect it to. You don't connect it to
if
ground.
you do that, you really have a problem now, right?
Well, that's in the
Now
church, for
welder,
the church.
Current goes out, comes back.
It's home.
You don't
It's
connect
like
it on
that's
the
just
table,
the
you
brother
connect it
out
to the
back
building
that's
somewhere,
out there. That
right? 'Cause you
photon
need
is in
ground.
that color,
And then
flavor,
also you
moving in
connect
that
this thing,
spin.
welding
Nothing
here.
anybody
Now
you
those
like to
electrons
do or
are
shit
going
will love
where?
about it.
All through your motor bearings.
all over the place to get over to somehow. Who knows? You might have a fire somewhere in the building because you got current.
Oh, you're not into something.
Right? That makes the machine work. Because the machine needs ground to work, and I'm just going to have the electrons go out one way, not realizing no. It goes out. It's going all over this building and getting back. Thank you.
Oh yeah.
Appreciate that. That was excellent.
Well, droid
Fact.
circuit down to the breaker. What room's rated off of how many light bulbs on something for a breaker limit.
Here's some examples.
A 100-watt light bulb times this many will give you wattage for any piece of equipment on there in the room. So that's code.
I'm not going to tell you the whole story, but I
Things would kick the breaker. You don't need a freaking light.
He's taking a shower in a barracks. He goes down and kills the bad guys, comes back taking that. There were 16 of these guys.
Okay.
Over Afghanistan and Iraq. You know
And he decided to bare ass naked that shower.
They have these showers. They have the metal water piping system. They have a motor that runs the water pump inside.
Got struck by lightning?
The water pump. The feeder cable that came to the building was it's a European kind of cable. It has it has an outer braid.
So 2 different codes already.
Effective ground fault current path. But when they build these buildings so fast, and the contractors who are not electrical people, probably wouldn't matter anyhow.
That's two
they made a
violations.
And the braiding of the cable did not connect to the connector to the equipment. So then when there was a fault,
Was it not up to code, or was it because of where? Serviceability. Some ground fund of heavage.
So now I'm involved in this case because the president of KBR company called me this whole deal.
You didn't want to pay.
You know what the solutions were? Drive ground rides at the buildings. And I'm like, no. And I'm going around and around and around in a circle. And I do get upset. You guys, the video stream guys saw me. You start killing
have
somebody.
paperwork,
Really,
electricity.
really bothers me.
Yeah.
You think after what I just covered an hour or so.
None of those things are important.
I go nuts. I go nuts on this engineer. I said, listen, here's what you got to do. You don't go out to like 20,000 buildings or 10,000 buildings and drag ground rods all over the place. You have to clear the fault. No. The electrons go to ground. It's the path. I said, listen, go drive a ground rod. Take your circuit.
I'd have to hit his teacher and understand from that. He gave me the information. Director or district attorney, that's where it sent you. AI. I'd have to hit it there to guarantee that it wasn't a serviceable ground heavage system. Well, like I said, because the payout comes down on that chew out later and friction heat. Well, it's where we put the toaster in the water.
They found out the ground rod that was driven for the service on this little tiny building was a 4-foot ground rod. And they're all like, oh.
Well, that would be probably just small in general, right?
The ground had nothing to do with killing the boy. What happened was, at the transformer,
6 gauge.
there was a jumper that was missing. In other words, you have to have current travel back to the XO terminal. That little jumper was missing. So when there was a fault, it energized the bus.
Well, then that's a no bueno. That's the only factor out of all this that mattered. And it's like I had to absolutely everything back to Omega blink of light.
Take a look at his other one.
Every day. Maintenance team. When's the last time they looked at the ground? When's the last time they went through the deck on the military and scrubbed the whole fucking flight deck down? Once you
heard of this until yesterday.
The house? When you do that, according to the house, a mechanic's supposed to come in my house every year, inspect my car.
W. Jordan man electrocuted, and I just froze, and I said, I wonder if that's West Jordan. I started reading West Jordan.
Careful.
Yeah, West Jordan. Well, I was born and raised in West Jordan, Utah. This is where I spent the first 25 years of my life was in West Jordan. So, You know, as an instructor, and Mike, I'm sure you can say this, I tell people all the time, man, people touch traffic signals and they die. People touch manhole covers and they die. That's in Vegas and that's in New York. Okay, well, this was in a little town in Utah. You know, this happens everywhere. You search hard enough, you can't have taken.
Well, you have to quantify stock as electrical engineering. You have to consider civil engineering as a supercomputer. Physics, the economics of a nuclear reactor are electricity, because output is electricity. And then that outloads into, they didn't have the connector hooked up over at the SCP Site 13 when we were doing the incident report. Elephant foot in the floor.
Here's another one. Boy electrocuted climbing a school fence. Here's another one.
Why is the school fence electrocuted?
Electrocution. I was involved in that case.
Oh, you are a champ. Look at you going to the rock. So when I say it is law,
this is on the internet. If you have this link on the internet, which we are going to put this whole thing on the internet.
It's always law. I always start with law. My career, bullshit. You should never trust me. You're my client. Do not trust anything. In fact, I assume I am the dumbest motherfucker on the planet.
You do. As a matter of fact, what I'm going to do now that I have this DVD recorded.
Until then, I'm going to say a word.
I'm going to put on the internet. When I get a call, a person asking me any questions having to do with grounding, I'm going to say, you know what? Do me a favor. Go to MikeHolt.com, go to videos, click on that. I want you to watch that hour and 15-minute video, then give me a call. Do you understand what I'm saying, guys?
I said I was a PhD in electrician.
Because you're so, when I say you're so messed up, I was so messed up until the 80s. Until I drove a ground rod one day because I was writing a book on electrical theory.
Out there with a sledgehammer.
And I found
I get
out
it.
I'm more. 25 ohms, 120 volts, 4.8 amps. It didn't make any sense. So I drove a ground rod. And I'm freaking out. Like you said, Scott, I am terrified this thing is going to blow.
This is an hour and 13 minutes of what you just trained your electrical engineer. You feel good about what you've done?
It didn't blow up. I put an ammeter, I measured 2 amps. I'm like, are you kidding me?
Are you kidding me?
Scott, you were with me near the beginning.
They come out there while we're, maybe like that. Maybe that's how they like it. You will get used to this, because we camp this out, maybe.
For the first time in the history of anybody I know of, that grounding does not clear a fault. All these things.
The office. Donnie wasn't afraid to fucking jump a wild horse. He could throw me in the office, sit me down, but not a lot of the other ones couldn't.
You saw it because you got on the code panel.
He was a preacher man. He wasn't afraid. He'd take married men and bend them.
5 years ago, none of this conversation that we're having
kill him, don't fuck kill him.
Cut it off, don't fuck cut it off. None of that would have happened. I tried for 20 years. But Code Panel 5 got more people to drink the Kool-Aid. And I think pretty much everybody in Code Panel 5 understands.
You making money? You like what you're doing?
I mean, it is like they understand what the difference is now. That wasn't that way 15 years ago.
I'm your boss. So that means I'm not your God. It means I'm not your supervisor. That means these numbers that I provided into the company's timeline, really specifically as observations. I fill in this job. I do this desk. I do this system. It is the safety guy. I mean, I'd love to give you guys the opportunity to sit off on, jack off, do nothing. You will at least provide yourself training on crew.
I taught it that way. In my books, it was that way. So,
well, if I'm out on that floor, undercover IMA, it's nice when the gig's busted. But
started by me writing a book on theory, making an experiment, slowly reading it, writing it, communicating.
I think I trust you for anything. Like, I wouldn't play that like I wasn't supposed to be exactly where my post on was supposed to be.
The fundamentals.
You know, one comment in all this talk on grounding has been, I just want to reiterate the scope is for 600 volt systems and less, which is...
That is critical. We started that. We're not talking about
electronics.
We're not talking about utility distribution systems, just within the electrical system work.
90 days.
Mike, any comments on you guys?
Also, just include data.
1 a day.
We're not talking about
1 day for 90 days. That's the test. I mean, how much? Well, you get the saw, right? That's the rollers, operations, the tear down serviceability, tear down all the motor, reservice the motor, change the brushes, maybe. Did you remember to turn off?
The audio cables and how they do whatever they're doing. We're talking about you are bringing in equipment grounding conductor. No, you're not putting a cheater on that end that I'd attach a plug. You are going to have an equipment grounding conductor. You are going to connect to the equipment. Yeah, but my sound doesn't work. I don't care if your sound doesn't work.
Did anything weird happen while I was gone? By the way, I'm just throwing that out there, maybe.
You go to links. There's a link there on audio. There's people who are experts in audio that know what causes the audio problem. And the solution is not to remove
all the way.
The equipment grounding
I wanted to drown this out. I wanted to make
not
sure
on audio equipment.
everybody.
That's not the solution, because that's not the problem. Ryan, any comments?
Yeah, I'll make a article too.
I'd say put me in this, and by the end of it, you wouldn't have that problem you had.
Every single thing to do in every installation specifically. And that's why it's so critical that
figure out who you give it to real quick, who the big alpha is in here, hack the code, figure out what fire it is, pass around, say this is what you should have broke it down to be, because that's what the breakdown of the beef is. Bullshit on the field, it goes over there, you use the rest for this, that, and the other. If it's not that way, it's not CERN. Well, it's beautiful when I go on here and hit that psychologist, scientist that I was looking for, a science lab. Got two bosses, suits down. He's the scientist, and obviously in the shop. I'm looking at these guys. Well, we found out some things about science, guy, and just some things about human nature, how people treat each other. And the guys are just like, fuck, I thought this was supposed to go the other way. Gonna come out here while my crew is lazy bastards, and now I come back around.
What Ryan is saying is that you got to understand the theory, you understand the principles. You can't move forward. I guess like playing any kind of sport. If you don't understand the principles or any activity, you don't even know the foundation. You're in the middle of some game, like, oh, I'm playing cards. I'm not quite sure what I don't know what the goals are. No, you need to have the base of the game, and then you can start practicing. Got it?
Like your old lady, because you'll be dead. Apparently, be spiking a 4-inch gauge out there.
Data center, and the guy's rack isn't working, or his whatever machine isn't working. You don't just eliminate all the fundamentals. There are no exceptions. The fundamentals
I'll make
are
my
the
Z-coin.
Just like in
I'll
a
be on my
sport
way.
or anything else.
Banging your way.
And I'm always a big proponent, as you've taught for years, Mike, that as we're getting into it, read it in the code,
She might be.
follow it in the code, know where it is in the code. But
There's
if
a timeline to it. We'll figure out the geodesics
figure
later.
out the code. Back up to the fundamentals.
Gotta bury you first.
That will help you coming forward.
Otherwise,
I love that. There are no exceptions to the fundamentals, right? This is physics.
That's why they're the fundamentals.
best man stuff. Not me.
Well, the fundamentals that Scott's talking about is basically it's going back home.
Mufasa.
It's going back to where
This is
we
not
came
the African Serengeti.
still
We get to have
believe
fun here. This
that,
is
you
a
know,
hard
and
interview.
this is the way
To
they're
do
trained.
safety
They've been trained
right,
this way
like
over and over and over,
the,
that everything
they'll
goes
walk
to
you
the
in
earth
the
and
building,
doesn't. It wants to go home.
and then
It
this
wants
is
to
the
go
danger.
where it was
This thing
created.
kill you. This thing could be right.
Transform.
Any of that down on through it, that will kill you. And I know you
gotta
wouldn't do
have that
that.
complete
But some of them only once in a while
So you
won't come
have
off
to,
and do it, which
read
is
the
different
code
kind of
book
dead
and
later.
learn it on your-
Setting
you
that
can't
up.
trust anybody and what they
You
say
need it.
most
It's gonna come up. You're
because
gonna
they were
do it.
taught
I'm just
the
gonna
old way.
hopefully
The
assume
old
that
way
you've
is not
come
the way
writing.
it is.
So
Fundamentals.
it's all programs down and dirty, small pocket stuff, paperback book, cell phone videos, clickety click. Electric, it's the law in Russia. If that dude sticks their hand in there, you video camera, they twitch, they die. Read a rule about it, throw it in the safety book. 1 to a billion. Let's say $1 million. This guy going out here burning it down. Instant report. Should have. Alright, well.